here's the idea. We can usually, or we can use this, this is like a dichotomous key almost. This is like something we can use to identify whether something's a parallelogram, a rectangle, a rhombus, or a square. So to start off with, what I'm saying is if I see that the opposite sides are congruent, right? You guys know this. You already are very familiar with parallelograms. If the opposite sides are congruent, then it could be a parallelogram. In addition, I need the diagonals not to be congruent. So the diagonals, the lines that go across it, if they are not congruent, and I do the distance formula and I find that the opposite sides are congruent, then it's a parallelogram, okay? But on the other hand, if I do find that these diagonals are indeed congruent, right? Opposite sides are congruent, and it turns out that the diagonals are congruent, then it's a rectangle, okay? So it goes from being a parallelogram to being a rectangle if and only if the diagonals are equal in length, okay? So we can use the distance formula for that. And we're going to do that in just a minute. So if I find that all sides are equal, okay, they're all identical in length, all the four sides are equal, but the diagonals are not equal, that's a rhombus, okay? But if I find that all the four sides are equal and the diagonals are equal, like this, right? If I find all sides are equal and the diagonals are equal, then this is a square, okay? Only if the diagonals are equal and all four sides are equal. So we're going to use this is just for the distance formula. So let me show you an example of the distance to our step sheet. So not all four sides are equal, opposite sides are equal, and the diagonals are congruent. So what kind of shape is this? A formula like this. So this is number one. It's on the back. It's on the back of your notes. Turn your notes over. So let's do a diagram first, okay? So let's imagine that this is my origin, and I'm just going to plot these points. So over 9 and down 4, let's say that's like this. So let's say that's A. And over 8 and down 2, let's say that that's B. And then over 2 down 5, let's say that that's C. And then over 3 and down 7, let's call that D. Now, obviously, that's not highly accurate, but it gives me something to work with just so I can think this problem through, okay? So there's my shape. And what I'm going to do now is I'm just going to think, what do I need to prove? If I'm looking to take this all the way down and make sure I can say for certain it's a rectangle or it's a rhombus, what would I need to prove? I'm going to prove that AB, okay, this side, is equal to CD. So I'm going to take the distance of AB and I'm going to compare it to the distance for CD. All right, and I'll do this in a different color. I'm going to take the distance from C to B. I'm going to find the length of this side, and I'm going to compare it to AD. So I'm going to take the distance of BC, and I'm going to compare that to the distance, right, of the opposite side, AD. And then that's just going to be the sides. There's one final step. I want to take a look at the diagonals. The diagonals go across, so it goes A to C and B to D, right? So I'm going to do one final computation. It's going to be the distance from A to C and the distance from B to D. All right, so I'm going to move a little bit quickly just because there's a lot of math to do. But see if you can, stop me if I'm losing you, okay? So this is going to be the square root. I'm going A to B, right? So it's these data, right? These points right here, 9, -4, and 8, and -2. So this is going to be the square root of 9 minus 8 squared plus -4 minus a -2. It's going to be -4 minus a -2 squared. So let's do that math. That's 1 squared is 1. This is like saying -4 plus 2. So that's 2, right? Squared, or -2, squared is a +4. So this is a square root of 5. So this is a square root of 5. I was expecting you all to know that. That's okay. This is 9 minus 8 is 1, right? negative 4 plus 2, that's negative 2 squared is 4. So that's 1 plus 4, so square root of 5. All right, so let's do the distance of CD. All right, and what we're looking for is to see the same number. It should be the same number if it is a parallelogram. It should have opposite sides equal. So let's do CD. So that would be 2 minus 3 squared plus, all right, so I'm using this data over here, C and D, 2 minus 3, and then negative 5 minus a minus 7. Negative 5 minus a minus 7 squared. All right, so let's do that math. This is 1 squared is 1, or negative 1 squared is 1. Okay, and then this is negative 5 plus 7, so that's 2. 2 squared is 4. So this is the square root of 5, just like you would expect if it was a parallelogram. Opposite sides are equal. All right, so then let's do BC. So the distance for BC, that's the square root of 2, or rather 8 minus 2. 8 minus 2 squared plus negative 2 minus a minus 5. Negative 2 minus a minus 5 squared. So this is 6 squared is 36, and then this is 2 plus 5, right? That's 3. 3 squared is 9. 36 and 9 is 45, right? Of course, Mr. Rose. Square root of 45, all right. And then the distance for AD, that is, we're working with this point over here, A, and this point right here, D, okay? So square root of AD, that's 9 minus 3 squared plus negative 4 minus a minus 7 squared. So let's do that math quickly. 9 minus 3 is 6, squared is 36. Negative 4 plus 7, that's 3. 3 squared is 9. 9 and 36 is 45. All right. And then let's do the diagonals. So it turns out the opposite sides are indeed equal. This side is equal to this side, and it turns out that this side is equal to that side. That's good. All right. We need to look at the diagonals to determine exactly what this thing is. All right. So the distance for AC, this is the diagonal, AC. Oops, let me pick a different color. Green, okay. Equals a square root of. So we're doing AC. So this one, 9 comma negative 4, and 2 in comma negative 5. All right, so it would be 9 minus 2 squared plus negative 4 minus a minus 5. Negative 4 minus a minus 5 squared. So this is 9 minus 2 is 7 squared is 49. Negative 4 plus 5, that's 1. 1 squared is 1, so 49 and 1 is 50. Right, so the square root of 50. All right. And then we'll do the other diagonal. So the distance for DB, or BD, however you want to say it. So it's going to be 8 minus 3. 8 minus 3 squared plus negative 2 minus a minus 7. Negative 2 minus a minus 7 squared. So this is going to come out to 5. 5 squared is 25. Negative 2 plus 7, that's 5. 5 squared is 25. So this is a square root of 50. So let's go back to our step sheet. All right, turns out that these diagonals are indeed congruent. So these are indeed congruent. This one and this one, okay? So let's go, it's a rectangle, okay? So we proved that it's a rectangle because opposite sides are equal. So AB is congruent to CD, and BC is congruent to AD, and the diagonals are equal. So AC is congruent to BD. Questions?